Hello and welcome back to my channel. My name is Amir, and in this video I'm going to solve the puzzle on day 23rd of the Advent of Code 2022. So let's get started then. We have been given an input like this. This is basically the position of elves in a 2D grid. They want to plant some plants in the grid, and the issue is that the plants cannot be too close to each other. And because of that, the elves will follow a very specific set of rules to get apart from each other. So let's see what the rules are. Here we have a smaller example. So there will be rounds, and in the beginning of each round, every elf will look at the 8 positions around him. And if there is no elves on those positions, they will decide to stand still. Otherwise, they will take a look at the direction north, then south, then west, and then east. And they choose the first one that consists of no elf, and then propose that position. After all have proposed their position, the positions that are proposed by more than one elf will be removed, and those elves that have proposed that position will not move, and the rest of them will move to the proposed position. So let me clear it out with the example here. At the first round, these two will look up. This one looks up to direction up, and these three are empty, so this elf will propose this position to go to. The same is for this one. This will look up, these three are empty, no elves in there, so this one will propose to go here. The same is valid for these two, the same thing that goes there. But this one looks up, there are two elves on these positions, so he will not consider going up. He will just look south instead. After north, they will look south. The south is empty, so this elf will propose this position. Then this position has been proposed by this and this elf, so this position is crossed out, and these two elves will stand still. The rest will move on. So from here we will move to this state. In this state, now the turn is number 2, and when we are in number 2, the north position will come to the end of the list. So it was like north, south, west, east. Now the directions are south, west, east, and then north at the end. So all of the elves will look at the south first. These two will look at south. It's empty, so this one proposed this one proposed this. The same goes for this one. This will propose this, but however looks south. There is an elf, so he doesn't consider going south. He looks west. West is empty. He will propose this one. For this, the south is taken, the west is taken, the east is not taken, so he will propose this position. And after this round, it will be like this. These two have moved down and everything is in place. Now this is getting interesting. In this round, this elf and this elf will not move because there are no elves around them, so they stand still. This one, we now look at west first because we are in round 3, and the north position and south position are in the bottom, so it's like west, east, north and then south. So this one looks west, he can go there, there is nothing there, so he will propose this one. This one cannot go to west, there is something there. He cannot go to east, there is something there. He will look north, it's empty, so he will propose it. And for this one, west is taken but east is empty, so he will propose this one. And they will all move to their positions because none of the positions is proposed by another elf, so they will end up here. And this is the state that all of them are away from each other, none of them can move, and we can break out. And in the end, the thing that we should do is cut out the borders that don't include the elves inside, so this one and this one, and then count the empty spaces in this grid. So let's go to the puzzle, let's go to the code and start coding. Actually, let me grab the data. This is the input, save, and let's start. So first I would like to have the neighbors. These are the neighbors for this cell. Then I need to, map the input to something that is much more easier to work with. So I will map these ones to 1 and these ones to 0. Like this. Then I need to have the number of elves in place so that I can at the end count the empty spaces. So next thing is that I need to do something for 10 rounds. So let's say right. Then I will have the list of candidates that have been proposed by the elves, and I will fill that one. So let's see. Okay, this is me going through every column and then going through every row and checking if that row is a elf, and that every neighbor around that is empty, is not empty, so to say, and then getting the candidates filled by this request function that we will write later on. So if this is done, then I need to do like count. So what is the request function? So request is taking like 4 parameters. One is the turn, that is the round, but I just rename it to be more clear in the code, and then the candidates. And so based on the turns, if it's 0, 1, 2, and 3, I will propose a direction, and the first direction that is available to the elf, that one is will be taken. So this is me telling that if the up or the top is empty, then push to the candidates that this position wants to go to this position. Then later on I will count these ones. So this should be done 4 times for every direction. Okay, either if any of these is available, then it will be added to the candidates, and then we will return. Okay, this part is done. The while is done. Now I need to count the neighbors that has been proposed. So let me check the candidates here first. This should be like this, I believe. Right, so I am getting the candidates. So this one wants to go here and this one wants to go here. Okay, now I need to count these ones and filter the ones that have been proposed more than once. So let's do so. This is me counting the candidates. I need to return it, of course. So now, as you can see, I have a bunch of ones and probably a bunch of twos somewhere. So like for example this one should be removed, and the ones that are proposing this should be removed from the candidates. So let me do that. So I'm just taking those ones that the count is 1. Right. So these are the candidates. Now it's clear that I need to say, okay, these froms and these are the twos. These space should be, this space should be 0, and this one will be moving to this position. So let me write this part too. But before that, if this list is empty, then none of the candidates wants to move or can move, then we should break. So not here. So otherwise, right. So this is been taken care of. Now our while is done after 10 rounds, and then we need to get the minimum and maximum and everything. So let me clear this one out and check the map once more. Yep, I'm getting the data. Cool. So now I need to get the minimum y and the minimum max and then maximum, and then count everything. So right, then when this is done, so I'm getting these values, then I need to multiply them and see what I get. Right, I believe this is going to work. 41, 46. Yes, this is the correct answer. Now for the part 2, let's see what we are facing. In the part 2, we are on the right track. Nice. In the example about the first round where no elf was found was round 20. So after 20 round, none of the elves has been moved. And we should look at the big example and say what is the number of the first round where no elf moves and they are distinct and away from each other. Okay, so the thing is, let me copy this here to part 2 and then bring this here. I don't need this part anymore, so no minimum and maximum and stuff like that. I don't need this one neither. I should go forever until I can break out. The candidates are the same. The request and everything is the same. The candidates count is the same. And in the end, I can just log the round. Nine five seven. Wow, surprisingly, part 2 was very short. However, I like what this puzzle. This was one of my favorite ones. Please like, share, and comment if you liked my video, and subscribe to my channel. It really helps me providing more videos like this. Until next day and the new puzzle, have a great day or night. Thank you and bye bye.